did I get to this particular topic? A couple years ago, with one of my previous employers, we were working on a set of classes, online classes and materials on secure coding and issues with the code and how to make your code secure and stuff. So they gave me this deserialization topic to research and prepare some material. And first I thought, well, that's kind of, I don't know, deserialization is not that exciting. It's pretty straightforward. But when I started looking into that, I realized that not only this is a very interesting topic, but also it's very broad and very deep topic. And there's a lot of stuff out there on the internet. And if you just want to try researching yourself, you might find yourself that like in a rabbit hole, basically. There's just too much, I would say. And one of the reasons is because deserialization is quite specific to a particular language, to a particular format that you are dealing with. And of course, the remediations are also specific to that particular language or format or framework that you're working with. So you cannot say that deserialization is a very standard topic that and as soon as you learn it, you know everything about it. No, I mean, there are common things, but there are also many things that are very different from one platform to another, from one application to another, from one language to another. So today we're gonna talk about a couple of really basic and common things. But we're not going to go very deep into this subject. The goal of this presentation is kind of give you a preview of how things can go really, really bad if deserialization is done wrong. So I'm going to give you a few demos, and I'm counting on the wow factor that you'll see them and you'll be like, wow, that's pretty cool. I'm interested, I'm motivated, I want to look more into this. So I'm just here to encourage you to do more with this material that I'm giving you today. Of course, we'll talk about how to avoid issues, but yeah. So first of all, what is deserialization? Well, imagine you have two programs that need to exchange data. And this program A on the left has an object in its memory. And it really depends on that program how that object is presented in the memory. But how can I give that data to the other program? And the way it's normally done is that object is converted to some kind of byte stream that can be sent over any kind of medium. It could be a network, REST API call, some endpoint parameters. It could even be persistent storage. So you send message to yourself, you store it, and you retrieve it later. So, OK. The program B retrieves that byte stream and then converts it back to internal representation of that object. And that's pretty much it. The red arrow on the left is called serialization, and the red arrow on the right is called deserialization. It's a very, very simple concept. Now, in terms of formats and languages, we can say that there are some binary formats. If you do native Java or .NET serialization or Python 3, then it would not necessarily be human readable. But we also have some human readable formats. And these are like XML, JSON. I mean, if you think about it, XML is some kind of a structured data. It is human readable, right? But you can imagine that it represents some kind of an object, and you can convert back and forth if you have the right library, the right software. Same applies to these other formats like JSON or any XML-based formats like so. For example, Google Protobuf is another good example of human readable serialization format. Of course, this is just a very short list, and there are a bunch of others, and you can read about all of them at this Wikipedia page. So let's just go and see how these things work in real life. So I have a very simple Java program. So this is a very simple class. It's called just a class. It has two members, ID and name. And I have a serializer and deserializer all in one program. So to serialize an object, I first, of course, need to instantiate that object. And then I do a couple of weird things. I create output stream and another output stream. These different kinds of output streams. But the important thing here for Java is that object output stream is the one that you use to serialize natively. And this write object method is the one that's actually doing serialization. When I deserialize, I create object input stream, and I call the read object method of that. And that's actually actual deserialization. And then I need to cast the result into the class that I'm expecting. So let's see how it works. I'm going to compile it first. And then I ran the program. It says that the object was serialized and written to this object.ser file. And then it read the object from that file. What is this file? This file is pretty small, but Linux knows about it. The file utility tells me that this is serialized Java data. Cool. How does it look? Well, it looks like binary, right? It's not necessarily a text file, but you can see some things that look like text. You can see the name of the class here. You can see one of the types, string. You can even see the data. The answer string is here. The first 4 bytes read ACD 0005 in hex. And if you see that kind of thing in the wild, you can guess that this is serialized Java data. If we base 64 this thing, the first 5 characters read R00AB. I'm highlighting them here. And that's the Java serialized data signature in base 64. So if you see these things, you can probably guess that you're dealing with serialized Java data. And that may be useful. Now, there is a utility. It's a free tool called JDeserialize that can interpret this binary object. So if I run that, it dumps everything it can gather from this little file. So first of all, it gives me the declaration of the class. So it is able to understand what this class is. It has 2 members, as we saw, right? Integer and a string. And then it dumps the instance of that class. There's ID set to 42, and there is the name is set to the answer. Awesome. So you can use this tool to interpret this binary serialized data, even if you don't have the source code and you don't really know how that class was built. OK, that's enough with Java. Let's move to Python. Python has a native serializer called Pickle. And it can basically serialize any kind of Python object, I believe. But in this case, I'm using a simple dictionary with a couple of items in it, name and ID again. But it doesn't have to be a string, doesn't have to be an integer. It could be just an array of bytes. I commented out for now, but you can just do that. You call pickle.dump, and it dumps that data into serialized format. You can save it, and then when you read it, you just read from the file, and you call pickle.load. Let's see how it works. Save and read. Expected results. Let's take a look at this object.ser file. Well, again, it's some kind of binary data, but again, you can see the familiar stuff like, text. If there was some text data, it will be present in this file. In other words, neither Java nor Python, even though they use binary formats, they don't really do much with the data itself. It's there in those files as is. And you can guess that you can probably modify that data and change it and do whatever you want. OK. That's basic stuff. Let's move to a more exciting thing and see an actual application. I have a very simple web application here, which has two sections. One is called insecure, and the other is secure. And that's for a reason. So let's go into the insecure session, and I'm greeted as a guest. How does this application know that I am a guest and not the administrator? Well, the first time I get into this app, it gives me a session cookie called user, and it's set to this value. Let's take a look at the source code. This application is written in Node.js. And the session cookie is a very simple object that has a name and a role. And the guest cookie is set to guest, obviously, right? So what is this? Well, this looks to me like base64 encoded JSON object, right? If you see the characters EY at the beginning of the data in base64, that's opening brace most of the time, and you can pretty much guess that this is JSON data. Let's take a look at that. I need to replace these weird characters with the actual characters and decode it. And yep, expectedly, it decoded to JSON. Cool. Now, well, the role says guest. If I look at the source code, I see that the source code is checking whether the role is admin. So can I just
All right, Alexei, you're good to continue.
OK, good. Thank you. All right, so we sent this new cookie to the application, and now we greet it as administrator. And that was this was really simple, right? And you might be wondering who is doing this, but you will be surprised. And if you have a career in security, you see all kinds of weird things, and stuff like that is not that uncommon. So people basically just trust on what they send to the user and expect to get it back without any changes, right? And that's because a lot of times we don't care about integrity. And when there is no integrity, there's no security, many times. So how can we make sure that the data that we get back is valid, it has not been changed, has not been tampered with? Well, there are ways to do it, like, for example, digital signature or HMAC. And let's take a look at the secure section of this application. And I'm sorry, my neighbor decided to mow the lawn. I hope it's not too noisy. But let me go and shut the window. Sorry for the interruption. Okay, I'm back. So let's go to the secure section, and we've got another user session cookie, and this time it kind of looks the same, but it's much longer. So why is this so long? And if we look at the source code, we see that we do some special thing here. When we generate our cookie, not only we put that JSON in it, but we also add an HMAC. And HMAC is a cryptographic thing that's based on a key, a symmetric key. And here is my key, which is super secret and super secure. No, not really. It's been exposed, so don't use it. But we rely on this. Well, we assume that this key is not known, right? It's only, well, and the other thing, it should not be stored in the source code like it is here. This is not a very good practice. It should be stored in like maybe environment variable or some kind of secret storage. But that's a subject for a different talk. So anyway, we add that HMAC, and when we receive the cookie back, we verify it and validate it. Now, if I try to hack this and replace that cookie value with my forged one and try to send it, well, I get unauthorized because that HMAC does not validate. So that's the kind of rule of thumb, that you need to validate the integrity of your serialized data. I mean, this is very, very important with serialization, because a lot of times you do not expect your users to tamper with serialized data, and you need to ensure that they did not. Well, unless your application is designed to accept untrusted input, in which case, yeah, you have to accept that. But in most cases, you don't. All right, let's take a look at another example. And this time, we're going to see a Java application. I have my Tomcat server here, and it runs this application that deals with serialized data. Well, let's say you're an entrepreneur and you designed a cool device, and you want that design to be manufactured and sold. So you go and find a factory that makes anything that you want. And let's say you designed an iPhone. That's a new invention. And you order 1 million iPhones from that factory. They manufactured them, and they sent the package to you in this file. Well, let's imagine that's a real package. Anyway, so you got that package, and then you need to give it to the store. You need to send those devices to the store so they could be sold. All right, you give it to the store, and they have just sold your 1 million iPhones, and you got the profit. Cool. How does this application work? Well, first of all, we have this the class called items, it's, well, of course, it's a proof of concept, so it only has name and quantity and nothing else. It's all right. And our store is receiving that object and is deserializing it. You could have guessed that we're dealing with serialized data. We just call this read object on whatever we receive through that web interface. Okay, and this is super safe, of course. Well, no. And let's see how it is not safe. Let's say the factory that we contacted is a malicious one. And instead of our items, it gives us some various things. And I'm going to save them all on my drive and try one after another. So the first one is string, The second one is some kind of 64 gigabyte stuff. I'm not sure I got 64 gigabytes, but we'll see. And the third one is CPU bomb. Well, first of all, let's take a look at those files on the disk. All of them are serialized Java data, including our original iPhones.scr, the legit package, and we also have some other things. So let's take a look and try to sell this string. Well, string does not sell, and we got an exception. And the exception says that Java lang string cannot be cast to class items. Well, of course, we expect items, and we get a string. That's not good. And well, we don't handle the exception well, but on the other hand, we don't sell it, which is good. Okay. But now let's take a look at this exception message one more time. It says, cannot be cast. Well, what does it mean? Well, that means, that tells me that I guess the object was actually deserialized. And then it failed on the next step, which was casting. So let's take a look at this line 27. Line 27 is our read object. So read object actually does return, despite the fact that the object that we got is not something that we expect. And then it is cast to this object that we do expect, and this is where it fails. So the bottom line is deserialization did happen, did occur, and we failed somewhere else. Well, if things can go really wrong during deserialization itself, then there is nothing here that will prevent it. And let's try a couple of these other things that we got. The next one I'm going to try is the 64 gigabyte object. As you can see on the disk, it's not really 64 gigabyte, it's only 114 bytes. But what happens is when I try to sell it, I get this connection was reset, which kind of suggests that the thread that was handling this request died. And it did die because this particular object causes the Java virtual machine, when deserialized, when the object is deserialized, to allocate 64 gigabytes of RAM. And I don't have that much memory on this little virtual machine where this application is running. All right, that's the denial of service of some kind. Let's try this other thing, CPU bomb. Well, this one is interesting. I push the sell button, and it doesn't return. And it's sitting here spinning this little thingy and never comes back. Well, so what's happening? Well, if I go to this virtual machine where this Tomcat server is running and look at the processes, I see that on the very top, with 100% CPU utilization, is a Java application. So what is this process? Let me So I have to really get rid of this process and restart the entire Tomcat. Here it is. Let's wait a second for it to come back. And it's back. Well, the lesson here is you can die by deserialization. This little object on the right is trying to consume 64 gigabyte of RAM, and that's not good. And the one that we just saw, this is the source code for it, and I borrowed it. I didn't not write it, so I don't take credit. But it's some kind of a tree structure. It's finite. It's 100 levels deep. It's using hash sets. Creates 2 hash sets at each iteration, and for some reason, Java Virtual Machine is having a big issue with this. When it's trying to deserialize this kind of structure, it never returns, and it's a known issue, and I don't believe it's going to be fixed. It's just the way it is. But it'll be, like I said, it's going to be sitting there and spinning all your CPU and never returning. Okay, how do we protect from this kind of things? Well, the answer in Java is class whitelisting. Now let's take a look how that's done. We have our secure store. And let's try to sell this 64 gigabyte object. And we get an exception. We get a nice error message saying that the store does not accept this whatever, right? The stores normally say we don't accept Visa or American Express, but this does not accept this object. Well, let's try to sell CPU bomb, and expectedly, it was able to detect that it's a hash set, not the items, and was not able to sell. How is that implemented? Let's take a look at the secure store. Instead of the regular object input stream, we use our own method, our own class, safe object input stream, which is a subclass of the standard class. The only thing that's different here is we override one of the methods called resolve class. The resolve class method is called every time the Java deserializer is seeing an object that it needs to deserialize. And it's called before the actual deserialization. And in this method, you can put all your checks in. In this particular case, I'm checking whether the name of the name of the input of the class in the input matches the name of the class that I expect. And if it's not matching, then I just throw a nice exception, and then I catch it, and I print that error message. But the cool thing here is deserialization never happens for the things that I do not expect. This will only deserialize the class that I want. All right. Yeah, we saw some nice denial of service stuff, but how about code execution? Well, apparently, deserialization can ultimately lead to remote code execution. And you might have seen that in the news, and let's see it in practice. I have another application here. This time it's written in Python. It's a very simple example with deserialization. In Python, achieving remote code execution is trivial with deserialization. This is my application. It's Flask app. Gives me a session cookie called hi session. This is basically a serialized Python object. It has a couple of items, user and access, similar to what we saw before with that Node.js app. I'm anonymous, I don't have any access, whatever. I'm not interested in escalating my privileges at this point. I am interested at running the code. All right, so apparently with Pickle, if you serialize any object that has a method called well, it's a class, and that class has a method called __reduce__. This method and its code will be packed with your serialized data, and it will get executed during deserialization. Well, that's pretty awesome. So we can just send our payload to the deserializer. In this case, I am going to run a netcat command with a reverse shell. Before I do that, let me start a netcat listener. And then I need to generate my payload. Here is my payload, which is base64 encoded Python object. I replace my cookie. And now I need to refresh so that cookie is sent to the server. And I immediately got the connection in my netcat listener. And I'm root. Where am I? I mean, this is a reverse shell to this machine, and I can do whatever I want. The lesson here is don't really use Python native serializer unless you just deal with your own data. If you ever accept something that you don't trust, this is not the right thing to do, because bad things can happen trivially. All right, let's switch gears a little bit and take a look at some prominent deserialization vulnerabilities over the last few years. First one I'd like to talk about is the Apache Commons Collections remote code execution. Let's say you have a web application that accepts serialized data, okay? And this application, normally any application would use some kind of libraries. You don't write all the code yourself. You would probably reuse some of the code. And you can use library X, library Y, Z, whatever. And one of those libraries happens to be Apache Commons library, namely Apache Commons Collections. But the interesting thing here is you don't even have to use anything from the Apache Commons. It just has to be on your class path, meaning it's seen and resolvable from this web application. Okay, so it's on your class path, all right? And your web application accepts serialized data. Cool. What can happen is an attacker can send you a serialized object with so-called Apache Commons gadgets. And this is a very interesting and deep topic, subject for a whole different talk. And there are talks on the internet if you're interested, and articles. We won't go into any details, but these gadgets would ultimately get you into trouble. And on this left-hand side is kind of like a sample call stack for one of these gadgets. You can see that initially we call this familiar read object, and then it calls the read object of a particular class. And then it goes into some weird stuff like invoke, get, transform. The ones that are highlighted in bold are the ones from the Apache Commons library. But ultimately, it gets runtime. And ultimately, it gets runtime.exec, meaning it executes some code. And in this case, it will execute code with user-supplied data. Really, really dangerous stuff. Now, again, is the problem here with the Apache Commons library that can do this kind of stuff? Well, many people think it is, but most people think, and I agree with them, that the problem is with your web application that does not whitelist. So Apache Commons do whatever it wants to do, but it is your responsibility not to pass bad things to that library. So that 5 years ago, when this was huge in the news and many big vendors and their applications got affected by this, the Apache Commons project did make a fix or a few fixes in the library that would prevent things like this. But the issue was not solved. If your web application continues to to do dangerous stuff like accepting input that you should not accept. Bad things can happen because guess what? Any one of these libraries, even though maybe Apache Commons is completely fixed, but as a matter of fact, it is not. There are still some methods that you can build the gadget chains on, but it could be any other library with those dangerous methods. Well, dangerous, I'm saying in quotes because, I mean, they're not. It's dangerous only if you invoke them incorrectly. So the bottom line is to fix your application. Well, I want to give you a demo on that. So let's go back to our factory, right? And see if we can get remote code exec. I'm on this. So this is the box where this application is running, where my Tomcat is running. This is my application stuff. And it also has this lib directory. And in the lib directory, I have a few Apache Commons jars. Now, again, my application is not using any of these. They just happen to be there for whatever reason, right? But the lib is on the class path by default. So my application can resolve all the symbols from these libraries. Now, of course, I'm not going to write my own exploit. I'm going to use a tool called Serial. It's awesome, awesome, awesome tool that has a bunch of exploits that you can use. And one of them is called Common Bean Utils 1. So it's using this bean utils library. And I'm going to give it a command to execute a reverse shell and store the result in this refshell.ser. Again, this is just serialized data, right? Now, let's go and run our listener. And try to sell the reverse shell. That sounds awesome. Ooh, we got a huge exception, right? Which is kind of a good thing, but that's too late. We already have our reverse shell. We are root again, and we can do whatever we want. Now, was that difficult to do? No. I mean, I just had to run this one command to generate the exploit, and I had to go to this web interface to send it. So anybody can do it. Any script kiddie can do it. OK. Another vulnerability a few years ago was an Apache Struts REST plugin. This time, it's XML format, not native Java serializer. But in this, this is an actual exploit. This is from a post request that sends the payload wrapped in that serialized XML file. And you can see some weird stuff here. Like you can see some shell, some whatever. This looks like a reverse shell, and as a matter of fact, it is. Well, basically, we have some plain Java code with an XML that's get interpreted, and during deserialization, it gets built into and executed as Java code. Another one, Oracle WebLogic. Same kind of stuff. This time it's SOAP, which is another XML-based format. And we also see some plain Java stuff like process builder and string that we pass to execute to it. Well, what can go wrong, right? OK, when I was looking at this, I wanted to try it myself and see how the actual exploit looks to take the screenshot. And I looked at a Metasploit framework, and I noticed that starting with 2015, Oracle WebLogic has a deserialization RC once a year, 15, 16, 17, 18, and 19. So if you continue the trend, we should see another one this year. But I hope that Oracle finally got it right and fixed all these kind of issues. But what it tells me is that these deserialization issues are really difficult to deal with. And you can miss a lot of stuff. And some of these were actually Well, there were partial fixes that could then be bypassed. Well, again, this difficult stuff. Okay, no more Java. Let's take a look at .NET. Well, .NET apparently can be vulnerable, or .NET applications can be vulnerable to bad deserialization. Couple years ago, there was an issue in CyberArk Password Vault. The CyberArk product, Password Vault, is, if you will, your enterprise level password manager that keeps credentials for all your privileged accounts. Very, very, very cool stuff. Very, very important, and something that we really need to protect. Well, this application had REST API, cool, for automation and whatever. And this REST API is, of course, authenticated with authentication token. This authentication token happens to be a serialized .NET object. And again, there's nothing wrong with that as long as you do things correctly. Well, apparently they did not. So first of all, there was no integrity protection, which means that anybody could tamper with that token and replace things in it and maybe get elevated privileges. I'm not sure, but no integrity protection, bad. The other thing was there was no class type validation. In other words, no whitelisting. So you could just send it any .NET object, not necessarily this authentication token, and it will just swallow it. As a result, .NET gadget chain was possible, which led to unauthenticated remote code execution. And the .NET gadget chains are similar to those gadget chains that we talked before in Java. They're not the same, of course. It's totally different language framework format, but the idea is the same. You kind of go one step at a time and pull the string and ultimately get to remote code execution. Well, when the researchers who found it, well, first of all, they did responsible disclosure, of course. They reported it to CyberArk. CyberArk turned it around. They fixed it. Good job. And then the researchers published it. And basically, this is the exploit. You run two commands. Well, you just need one command, really, the first one, to generate the payload. And you do it by using ysoserial.net tool, which is similar to the Java tool that I used before. And this other command is just to send that payload to the server, and you get your code exec. I mean, how difficult is this? Again, anybody can do it. So let's do it now. And for that, I, of course, need a Windows machine. I do not have a CyberArk, but I have a similar application called CyberPark, which has an API REST point. And it's a very simple API that just returns something to me. If I don't give it anything, it gives me a sample authorization value. I need to authorize myself to this API. So here it is in command line. I can just call it without parameters, or I can call it with the authorization header. So if I give it that sample value back, I get foobar. This is just an example. But if I want to do some real thing, I would definitely want to run a calculator. So I would generate a payload using y.serial.net tool, which I precompiled on this machine. And I'm just using a few parameters exactly pretty much like in that exploit that I showed on the slide. And now I'm giving that file, I'm sending that payload in authorization header to the application. And I get my calculator. Of course, again, like we saw in Java, I got my exception. The type doesn't match, whatever, but it's too late. I got what I wanted. All right. If you are an attacker who wants to maybe pen test an application or do whatever you need to do, reverse engineering is a friend. You can use any tool or method you like, anything you're comfortable with, but a lot of times you would have to do some kind of reverse engineering unless all the source code is open and there is a lot of documentation, or you can talk to people who know about this. But most of the time, you need to understand what's going on, what formats are used, what the application is doing, how it sends the data, how it receives the data, and so on. In terms of generating payload, there are cool tools. Whitelisting, the one that we used in this demo, in this presentation, a very, very cool tool. And it's still, I mean, it was written a few years ago originally, but it's still valid today. These issues do not go away. You can use it, and you can use it for fun and profit. Whitelisting.net, the one that we used just a couple of minutes ago for .NET, similar tool for payload generation. There are some burp extensions to analyze serialized data in your web application traffic. You can search in the burp app store. I think there is about 5 or 6 of them. And a lot of times you will probably need to write your own code. Maybe you want to do something interesting, like in one of the exploits that I had to do for proof of concept with deserialization, I had to use part of YSO serial for Java and then wrap it in my own code to disguise the payload as another object. And it was pretty cool. It worked, but you might have to write your own code, and you need to be, to some extent, comfortable with doing that. So takeaways. Deserialization is cool, but it can be dangerous. It has its place, but you can't put it everywhere. You need to understand what the dangers are. I would say don't use it at all. Like, if possible, don't. Well, but we have to use it, right? Even like at the beginning of the presentation, I said that JSON is serialization format. Like, everything is JSON these days, or XML. So yeah, we have to use it. But we need to validate all the input. We consider it untrusted. Everything is untrusted, unless you can authenticate that data. So if you do HMAC or digital signature or some other kind of cryptographic thing that would make sure that data has not been tampered with, that's what you need to do. Because as we just saw, bad deserialization can get you in real trouble, like broken authentication, authorization, privilege escalation, and even remote code execution. And last but not least, the third-party components can be vulnerable. And you need to have your patching program up and running. All this code that I showed you today is on GitHub. Feel free to download it, and it's very simple to use. You just need to have VirtualBox and Vagrant. And you just run a Vagrant app and creates a virtual machine for you with all this code running, except for the Windows example. You need a separate machine for that you need to build yourself. But everything else, Java, Python, what else do they use? Node.js, right? It all runs on that Linux Vagrant machine. You can contact me on Twitter or LinkedIn. And thank you very much for attending today's talk. And good luck.